All right, so this is the review for your Quizizz. Some of yours on your paper don't show this, so please make sure that you either have gone online using the code your teacher provided or that you copied it from them when they showed it to you. Okay, so working these out, exponent rules. Simplify using exponent rules. Anytime you see a number outside the parentheses, that tells you how many times you need to write what is in here. Well, let's see. This part, apparently I need to write it 0 times because anything to the 0 power equals 1. So this whole thing equals 1. So do I really need to multiply something by 1? No. So don't even write that part. This part I need to write 2 times. So we have 4rp3q squared. There's once. And we need to write it 2 times. So you've got another one. 4rp3q2. So that's what the 2 outside means. Now we're multiplying. So 4 times 4 is 16. An R and an R, so that's R2. P3 gives you P6. Q2 gives you Q4. I'm getting these numbers by adding the exponents. Because if you remember PEMDAS, when you multiply, you add. So that's how I got those adding those exponents. You can also expand it. This is a 4, an R. P3 means write P 3 times. 1, 2, 3. Q 2 times. Then we've got a 4. R. P 3 times. 1, 2, 3. Q 2 times. Q. Q. So 4 times 4 is 16. I've got 1 R, 2 R, so R2. 1, 2, 3, 4, 5, 6, so P6. Q, 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 Q. So 1, 2, 3, 4. So Q to the 4th. So my answer is right here. Okay, simplify the following. Okay, this time it's not raised to the 2nd power, it's raised to the 3rd power. So how many times do I need to write it? 3 times. So we have 3ab2, 3ab2, 3ab2. So 3 times 3 is 9, times 3 is 27. So that automatically eliminates C and B. And then I've got A, so A3. That already gives you your answer, right here. To finish it, B2 plus 2 is 4, plus 2 is 6. Remember, you can also expand it like we did up here. So 3ABB, 3ABB, 3ABB. Now, for those people who don't want to expand it, which I don't know why you wouldn't, because it takes 2 seconds and helps you get the right answer. But what you're doing is you're distributing this 3 to every single part. So you have 3 to the 3rd power, A to the 3rd power, and B to the 6th power. That's how we're getting that 3 to the 3rd, that 27. Okay? Which step is needed when simplifying this expression? Okay, so we're multiplying. So do you need to multiply the coefficients? You bet you do. Multiply the exponents? No, when you multiply, according to PEMDAS, when you multiply, you add the exponents. Add the coefficients? No, you add the exponents. Raise 2 to the 4th power. I would if the 4 was outside, but it's not. So my answer is A. Okay, here. How many times am I going to write it? Not at all, because it's 0, so your answer is just 1. Anything to the 0 power equals 1. Please don't miss that question. That's crazy easy. Rewrite in radical form. Anytime you're thinking about radical form, think of a tree. Okay, where does your tree get its power from? Up at the sun, so that's the power, and the roots are down below. Okay, so which number is below? The 3, that's your root. So it is the 3rd root of A. The number on top is your power, so that's a power of 2. So 3rd root of A squared, so D. Okay, square root of 243. Okay, we are simplifying. Okay, there is a calculator trick, if you can remember. you can go to y equals whatever number we're taking, so 243, and divide by x squared. So you're looking on the table, 243 divided by x squared. You know, when we did factoring, we just divided by x, but because of that square root, that's why we're doing the x squared. So you're going to go on the table as low as we can with whole numbers. Ooh, there's a whole number, 9 and 3. So your answer is 9 square root 3. And that's your answer. Now, let's say you forget the calculator trick. This is where you're creating your tree. So I'm going to take 243 and break it into its factors. Okay, so let me see. 243 divided by, let's just go old school. So 243, what's something you think it divides by? Ooh, maybe it divides by 3. Yep, 3 and 81. Okay, 3 doesn't break down. What about 81? Now I know that's 9 and 9. Okay, 9 breaks into 3 and 3. And this 9 breaks into 3 and 3. Nothing breaks any lower, so we look for some twins. There's some twins, there's some twins. One gets shot, one breaks out. One gets shot, one breaks out. And who's left in jail? This guy over here. Now, they broke out of jail, so what are they going to do? Multiply. That's right, make some babies. 3 times 3 is 9, and that 3 is still left inside. Which of the following is equivalent to this expression? Do you see any variables here? No. Anytime there's no variables, just go on your calculator, the home screen. You just got to be careful that you use parentheses around those fractions. Okay? So I go to my home screen. We have 8 caret, and then 7 divided by 3 times 8 caret, parentheses 2 divided by 3. 512. All on the calculator, easy as pie. Now, let's say you struggle with typing things in. What we're doing is we're multiplying. So according to PEMDAS, when we multiply, you should be adding your exponents. So we have 7/3 plus 2/3. That's 3. So really this is just 8 to the 3rd power, which is 8 times 8 times 8. 512. Which of the following is equivalent to this expression? Again, do you see any variables? No, so type that sucker in. So go to our home screen, 100 caret 1, oh, we got to put in parentheses, 1 divided by 2, 10. Now, if you're wondering how we got this answer, think of your tree. Okay, the power's on top, the root is on bottom. So it's the square root of 100 to the 1st power. Well, what is the square root of 100? 10. Okay, we are multiplying. Now, negative exponents, this is like a kid who didn't get the locker that he wanted in middle school. Okay, so you know some people are really short like me, and they got a top locker, and they were sad because they needed to be on the bottom. Some people who are really tall got a bottom locker, and they want a top locker. So anytime you see these negative exponents, think of them as getting the wrong locker. You need to move them either from the numerator to the denominator or the denominator to the numerator. So here we don't have anywhere to move them. So let's give them that line. This y3 needs to go down here, and this y3 needs to go down here. And then I'm going to use expansion. Okay, so we have 3 times 4, x to the 3rd means x, x, x. Over y3 and y3, so y, 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 y. 3 times 4 is 12. X, x, x is x to the 3rd. On the bottom, we've got y, 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 y. So y to the 6th. And there's your answer. Okay, so here we got some more sad locker people, so let's just go ahead and take care of those first. So this y4 is going to the bottom. Okay, this y3 is going to the top. this Z3 is going to the bottom. Okay, then I'm going to use expansion. So I've got a 2x, x, 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 y, 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 because this tells me to write y 3 times and x 4 times. On the bottom, I've got a 3, x, x, z, 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 y, 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 z, z, z. So z 3 times, y 4 times, z 4 times, x 2 times. Now, we're going to cross off anything that's in common. So this x and this x, this x and this x. This y and a y, y and a y, y and a y. There's nothing else in common. So on top, I have 2 and then x squared, because there's x 2 times. On the bottom, I have a 3. There's 1 y left. And then 1, 2, 3, 4, 5, 6, 7 z's. So z to the 7th. So let's see, 2x squared on top. So that's got to be your answer right there. And then 3yz to the 7th on the bottom. Which of the following functions shows an initial amount of 15 that doubles? Doubles means times 2 each year. So it's starting with 15, so y equals 15 times 2 to the x. Where does it start? How does it change? To the x. So my answer is B. What is the rate of growth for this exponential function? Okay, so it already tells us it's exponential. So if you remember the calculator steps, go for it, right? Stat, enter, type them all in, and do stat, write 0 for exponential. So I'll write that down in case you remember. So stat, enter for your points, and then stat, write. If it was linear, I would have pressed 4, but since it's exponential, I press 0. And then enter until you get your equation. And that could work. You can also just think y2 divided by y1. Normally we do y2 minus y1, but since it's exponential, we know that means multiplying, so to undo it, we divide. So we're taking y2, which is 12, divided by y1, which is 4. You could pick any 2 points on the table. So I could have done 36 divided by 12. I could have done this bottom one, 324 divided by the term before it, which is 108. All of these will equal 3. And that is your rate. So what's happening is here to here is times 3. Here to here times 3. So check yourself, okay? Especially if it's multiple choice. How am I getting from here to here? 4 times 4 would have been 16. 4 times 8, 32. So no, none of those work except for 3. Here, for this function, what does the 300 represent? Just like we talked up here, you've got the equation y equals a b to the x. The a is the initial value, or the starting point. If you couldn't tell, if you didn't remember that, plug it in your calculator. Let's look and see what's happening. So 300 parentheses 1.16 to the x. What's happening? 300. Where do I see a 300? Ooh, right here with 0. So it's my y-intercept, or it's my starting point. What is the domain of the function shown below? So remember robot dealer? Domain is left to right. This has an arrow. How far to the left is it going to go? Woo! Forever. How far to the right is it going to go? Woo! Forever. So if it's all the way to the left and all the way to the right, it is all real numbers. That is for every single exponential function. So what about the range? The range is also the same for every single exponential function. Okay? Range, that's our robot. Bottom to top. So where's the bottom of this graph? Ooh, it looks like it's at 0, right? But does it actually touch that 0? No, because it's an asymptote. So the bottom is at 0. Doesn't touch it. And then where's the top at? I don't know, because there's an arrow. So that could be your answer. Or if you think logically about it, right? The bottom is at 0. And are they always above that 0 or below that 0? They're above. So your y has to be greater than 0. What is the horizontal asymptote? Well, we just said right up here, we didn't include that 0 because it can't touch this. All right, you cannot touch that asymptote. Get as close as you want, but you better not touch it. Can't touch this. Can't touch this. So if you go down here, it cannot touch wherever y is equal to 0. So B is your answer. Guys, another name for this is the x-axis. Sometimes you'll see them write it like that. So you've got to be sure that you know that the asymptote is the x-axis, or the line y equals 0. So the table represents an exponential function. So if you remember your steps, stat, enter, stat, right, 0, you can get your equation. But I'm going to write it by hand, okay? So y equals, where does it start? At 1, times, how is it changing? How do I get from 1 to 4? Or what is my y2 divided by my y1? 4 divided by 1 is 4. 16 divided by 4 is 4. So my rate is 4 to the x. So I'm going to plug that in my calculator. 1 parentheses 4 caret x. Then we go, and we're looking for f of 5. Remember, that is inside parentheses. If you make the little motion with your arms, inside is the x value. So when x is 5, it is 1,024. And that is your answer. Now, you could also just continue it. Times 4, times 4, times 4. This is the 4th, 5th. And I've done it that way. So 64 times 4. 64 times 4 is 256. 256 times 4 is 1,024. Which of the equation below represents the table? Okay, so that's what I did above, right? We need to know where it starts. So which one of these means where it starts? This one. So where does it start? At 36. How does it change? How am I getting from here to here? So we take y2 divided by y1. So 108 divided by 36. 108 divided by 36. So that's 3 to the x. So 36 times 3 to the x. B. If you weren't sure, plug these in. See which one matches the table. 36 times 3 to the x. At negative 2, does that equal 4? Yes. At negative 1, 12, 0, 36, 1, 108, 2, 324. Yes, they gave you equations. Plug them in your calculator. This is how you're going to pass the STAR test. If you can use your calculator, you're golden. Okay, the value of a car is $15,000 and depreciates. Do you know what depreciate means? It means it goes down. Rate. Anytime you see a rate with a percent, change it to a decimal. So you move it left 2 places. So 0.08. What is the value of the car after 1, 2, 3, and 4 years? So depreciating means it's going down by that percent. What do we always compare it to? 1. So our equation is 15,000 times 1 minus 0.08 to the x. 1 minus 0.08 to the x. Okay, so now let's go to the table. So at 1, it's 1380. Yep, okay, so this one or that one, not D, not A. At 2, it's 12696. Okay, 3, 11680, and then 10,746. So that is your answer. These are the x values they're giving you, and it wants the y. Okay, this graph represents the decrease of the population of bacteria over time. Which inequality best represents the range? We already said it is the same for every single exponential function. Range automatically means y, so you could eliminate b and you can eliminate a. Now, if you're talking range, how low does it go? So range is bottom, so the bottom is here at 0, and notice it doesn't have the line underneath. And where's the top at? Why is the top at 150? Look at these elapsed hours. Can you have negative time? No. So really, none of this is included. So the top is at 150. If it had just said for the equation, it would have been y is greater than 0, but because it's the situation and you can't have negative time, that's why it is from 0 to 150. Which represents exponential decay? So decay means it's going down. That's going up. No. This is not even like the curve. This is a quadratic, if you'll remember that. So it's not that one. This is linear. Nope. Exponential decay. So it is D. Suppose a culture of bacteria begins with 5,000 cells. Ooh, 5,000, that's the beginning. And dies by 30%. Change it to a decimal. 1, 2. So 0.3. Write an equation that represents the situation. If it's dying, it's decreasing, and we always compare it to 1. So y equals 5,000, and then it's 1 minus 0.3 to the x. If you like the 0 at the end, you can put the 0, but you don't have to have it. So it starts at 5,000. It's dying, so it's not a plus. I don't even know where this x squared came from. That makes no sense. So your answer is A. Almost done. Which sentence best describes the sequence? Each term is 4 more. 2 plus 4 is 8? No. 8 plus 4 is 32? No. Each term is 1/4 of the term before it. That's not 1/4, it's getting larger. Each term is 4 times. 2 times 4 is 8? Yes. 8 times 4 is 32? Yes. 32 times 4 is 128? Yes. So 4 times, starting with 2. Did it start with 2? Yes, it did. So here to here times 4. Here to here times 4. Here to here times 4. What are the first 4 terms of a geometric, okay, so you know you're multiplying, with a ratio of 2, so that means times 2. The first term is 6. So 6 times 2, 12. 12 times 2, 24. Yep, 24 times 2, 48. That's your answer, very first one. Let's just see. This, it's not times anything. It could be plus 4, plus 4, plus 4. We don't want plus 4. We want a ratio of 2. Here, this is plus 2, plus 2, plus 2. Geometric and ratio means you're multiplying. Write the explicit formula for the geometric sequence. Okay, it's a sequence, so this means you're going to be using that n minus 1, right? So you say, where does it start? Y equals 162. What is the rate? So to find the rate, you take y2 divided by y1. So 108 divided by 162. Let's go on my calculator because I'm good at math, but not that good. 108 divided by 162. Then I do math, enter, enter. So 2/3 to the x minus 1 because it is a sequence. And the reason why we have to use this x or n minus 1 is because this is the first term. Remember on all the tables previously, we've used the 0 term to see where it starts. So my answer is A. And you could have eliminated this is more than 1. So it can't be that one because that would have been growth. That would be making it get bigger. This one is huge. It doesn't have it starting at 162. It can't be that one. This one has you adding. That's not geometric. That's arithmetic. All right, the area of a rectangle is 20x to the 7th, y to the 5th. If the length is 4x to the 3rd, y squared, find the width. So because they're giving us area and the length and they want the width, we're dividing. So 20x7, y5 divided by 4, x3, y2. Okay, I'm going to use expansion because it works every time. So we've got 20, x to the 7th is x, 2, 3, 4, 5, 6, 7, y5, y. On the bottom, we got a 4, x, y. Okay, so 20 divided by 4, that's 5. So eliminate those two. Cross out an x, another one, and cross on a y, another one. So we are left with 1, 2, 3, 4, x to the 4th. So we got 5, we got x to the 4th, and then 1, 2, 3. So y to the 3rd. So there's my answer. All right, good luck on your test on Friday. Remember, it's the last test before your STAR test. So you got this.